Alright, so we start now. Okay, so we continue from where we left last time. What was my last question? How do I make this neural network? See, you are experts of neural networks by now, and if you are not able to make it, nobody else will be. No, not me. Yes, I want to make a neural network, and neural network structure is pretty easy. There is an input layer, there is a output layer, and then you can have as many hidden layers as you want. As you can figure out, hidden layer is not at all my problem in this case as well. I can fill in whatever. Problem is, how do I prepare my input layer and my output layer? So I have problem with the neural network structure. So why are sequence to sequence problems special? Help me write the reasons. Why are sequence to sequence problems special? So, how to define, not define, what will be the right word? How to determine the structure of the neural network? Okay, and what will be the next problem? What is the other problem in sequence to sequence problems, in particular language problems? Training data is not a structural problem. Exactly. So how to represent each feature of the input. These problems, both of these problems were not there during computer vision. Computer vision, we had good matrices, every pixel was a feature, okay, and matrix was being stored as it is. Whether you flatten, whether you do CNNs, you were able to do everything nicely. In this case, we suffer from these two problems. So how to determine the structure of the neural network? We are not there yet. How to represent each feature of the input? We said, okay, we want to, so let me draw it again now. So Taj is in Agra. And I don't have any idea what will be my x1, x2, x3, x4. I don't have an idea what will be the output layer. Okay? Yes. How do I sort this? Yes. 16. So Taj will be a vector. This will be a vector 4 cross 1, this will be a vector, and this will be a vector. So I will have x1 to x16. And then how many neurons you want in the hidden layer, for example? 32? I won't be able to draw 32. So let me make my life simple by keeping just 4. Because 16, so 4 is fine. What will be the output? How many neurons in the output? 4. So let me just make it this. What is wrong with this? What is wrong with this still? You can figure out. It's a super easy problem. Right, so that's a very good thing, because all these 4 numbers will interact with everyone there. Okay, but that's a deeper problem. We won't go there. Right now, tell me, what is the superficial problem with this?
Sir, because in this you have to consider a word, not character. So अगर एक एक जाएगा उसका तो character जाएगा सर.
No. So now we have changed our input to one hot vectors. So when you say Taj, assume this is the representation of Taj. So this is the representation of Taj and will remain forever this, unless my vocabulary changes. Okay? Yes, come back here. I am going super slow, but people don't appreciate RNNs until everything is clear in their mind. Yes.
Good or wonderful दो words थे.
अरे यार तुम बहुत आगे चले गए हो, मेरे को तो छोटी सी चीजें नहीं आ रही हैं अभी. यस यस हिंट.
सर इसमें वैल्यू सिर्फ 10 है तो उसकी दिक्कत हो सकती है. आपको पुराना कोड से नहीं.
हाँ, ट्राई इट आउट. दिस इज न्यू. बिकॉज जब ये लास्ट टाइम कराया था रिकॉर्ड नहीं हुआ था. यस, व्हाट इज प्रॉब्लम विद दिस भाई? सब मोबाइल में लगे हुए हो.
सर इनपुट सिर्फ 10 के फॉर्मेट में.
यस, इनपुट. यार, if my sentence changes to Taj is in Agra, which is in Uttar Pradesh, my neural network will not be able to take care of it, because it was designed to input only 4 words. And this is a super big problem, because sequences will always have different lengths. My sentences will always have different lengths. Now, if you start talking about context as in LLMs, even though that's a different story, but just having 4 is not sufficient, right? So we'll come to that whenever we'll come to that. But this neural network is hard coded to take how many inputs? Just 4 words, and that's a very big limitation. We don't like it. We are back to square one. How do I make a neural network? If I am doing sentiment classification, is it easier to draw this neural network? At least this side, yes. Why? Because what will happen in case of NER, if 5 words are there, I will have output also, I will need output also 5 neurons. So both my input and output will be a function of the length of my input, and there I am doomed. I don't know how to handle such a thing. Excellent. And how will you do that? So you want to represent this whole sentence as just one scalar. That's what one neuron means. How will you do that? जो सो रहा है उससे मेरे को प्रॉब्लम नहीं है, सोने वाले सोते रहे. यस,
सर इनपुट जो लेने का तरीका है तो यही रहेगा कि
थिंग्स विल चेंज ड्रास्टिकली. यस, neural networks will look similar, but now we need to take care of these problems. So first, let's say we talk about how to represent each feature. Okay, right now we will stick to one hot vectors. So right now we'll stick to one hot vectors, and let me just remove this cross. बेकार में लगा दिया था, ठीक है. So I am solving named entity recognition right now. So named entity recognition में my output is sorted. How should my output look like? Named entity recognition में how should my output look like? Sorry. It's a binary classification problem for each word. So does this help you? It's a binary classification problem for each word. In fact, let me just keep this. I'll make another network here side by side. Yes. Does this help you? Not this, but whatever I said. I am going to input only one word at a time and I will output 0 or 1. How do I input Taj? And then let's say I have 3 neurons here, I have 1 here, I will get either a 1 or a 0. In this case, this is Taj, so I will have 1. Can I input is? I think this was is. In, this was in. Agra, this was Agra. So I can input everything word by word. I don't suffer from this limitation that I can't take input anymore. But what is wrong with this structure? It won't learn the relationships. But see, when you were doing, so here what is the example? In this case, what is example? Taj word is one example or the whole sentence is an example? Whole sentence is an example. Maybe whole paragraph is an example, right? Maybe whole document is an example. So in case of CNNs, what you were doing? One input, image will go. Cat is there or not? Then next image will go. Here each word is not a segregated input in itself. Here each word is just part of a sequence. So in itself it does not have any meaning. It basically takes its meaning only when seen as a whole. Okay. So this particular thing, my neural network structure is taken care of, my input is taken care of. Problem is language does not make sense. So we'll come to that. Anyone else? भाई कोई और इनपुट का तरीका बता दो. I'm stressing so much because otherwise it is not really evident why RNNs are different. RNNs are not same as DNNs, they are not same as CNNs. You cannot convert a RNN to a DNN like we converted a CNN to a DNN and vice versa. Yes.
सर आप कहते हैं सर मैं वर्ड बाय वर्ड देंगे उनको सिंगल नेटवर्क में तो जो तक आउटपुट आ रहा है बस मुझे प्रोसेस करके सीक्वेंस देख सकता हूं लाइक 1 मिलेगा तो पहले फिर 0 फिर 1 तो आउटपुट को पकड़ सकता हूं सीक्वेंस क्या है.
See, so help me, if this is my neural network, how will my input data set, how will my data set look like? Give me the examples in my data set. My example is Taj is in Agra. Taj output is 1. This is my first example. 0, 0, 1. This is my table. This is my CSV. This is how my CSV looks like. Taj ke liye I have 1 is 0, in 0, Agra 1. And if you have millions of sentences, you will have a table with millions of words having ones and zeros and so on. Okay. So how will, so I have created a data set like this. How will that work? Input Taj 1, input is 0, input in, input Agra 1 and so on. Will this work? No. Will this work in terms of the structure of the neural network that we have been seeing? In that case, yes. So this is fine. This works. If I give input as one hot vector, I give output as this, I have an input, I have an output, I have a mapping, I can give input here, I can get output here, this works. at least as far as the structure of the neural network is concerned. But the problem is, it does not give you any output. I mean, all the accuracies are super bad, you better don't do this. So then how do we fix accuracy now? We are done with the structure, how do we fix accuracy? How can we fix accuracy? No, how can we fix accuracy in the sense that right now we have just fixed the neural network. We like this structure. There is an input, there is an output, and I want to learn this mapping. Right? You can categorize the words. So remember, when you say this, there are more than 1 million words in almost every language. Would you want to categorize 1 million words? And then every day new words. So there were these two words added to whichever dictionary, I don't know. But Bangalore, what does this mean? And then there was another word called Shanghaied, which means kidnap ho gayo. Okay. So new words keep on adding. That's a doable thing, but not doable. Yes. How do I prepare input? ऐसे उबासियाँ ले रहे हो ना सुबह 10 बजे की क्लास में. Yes. So now I'll talk about this problem. How to represent each feature of the input. Okay. How to determine the structure of the neural network? We are almost there. But how to represent each feature of the input? I could add more structure to this, but maybe not today. So we start with representations. Okay. Because right now our bottleneck is, how do I represent words? Okay. And if you, it is worth showing. Right. So if you see this figure, this figure became very famous, right? If you see this figure, this one, okay? If you, so this is the tree of all large, not all, large language models until the beginning of 2023, and you see this is already exploded. But if you see in the roots, you see FastText, Word2Vec, Glove. These three are those algorithms that try to find representation of words. So everything starts there. So now we'll start with Word2Vec. I don't think we have enough time to go through Glove, but I'll just try to scratch the surface. So what is Word2Vec? everything that we'll talk about now, at least in terms of neural networks, you have an idea. What is word to vec? So हर एक वर्ड का nice. And then which one will you choose? So, I have this particular statement. Just fill in the blanks with one word. Water. So I'll start with here, water. Yes. All right. Juice. I heard wine. More. Coffee. अब ये विस्की वोदका ये सब मत करना लगे. हो गया एक वाइन. एक और करा दो, बियर कर देते हैं बस. हाँ ठीक है. Yes, please give me a glass of. Just one word. So don't say orange juice. Right now, that is not allowed. Yes, more. Juice is done. Milk. हाँ. अब मिल्क बोलते फिर छाछ और ये सब शुरू हो जाओगे तुम लोग. But fine. Okay. So assuming English has some, assuming let's say जो assuming vocabulary size is 100k or 30k. Assume 30k is the English vocabulary size. Even though the maximum number of words in English will bypass 1 million, 2 million, but let's say with 30k top used words, you can talk about a lot of sentences, right? A lot of them, balki all of them almost. So please give me a glass of this. How big can this list be? If we start enumerating every word and check whether it fits here or not, how many will be there? Right now I am assuming our vocabulary size is 30k. So please give me a glass of car according to you is a right completion. Please give me a glass of bus, truck, road, fan, tube light is according to you a correct completion here, right? I repeat my question. How many words will be a good candidate to come here? 1/4. All right. So give me 1/40th of your 1/4. $1K? Maybe 1K, but I still think 1K is a very high number. So 30K, right? 30K का 1% कितना हो जाएगा? 300? So 300 is a good number maybe, right? So let's say 300 are good candidates here. But even in that case, which candidate, so now start making a probability distribution. Please give me a glass of. Doesn't this word win by far? So let's say 50% of the times you have water there. Let's say some 5% of the times you have juice, and let's say some 10% of the times you have milk. And you just keep on doing this. Okay? The sum of these percentages will of course add to 100. How many times you will say, please give me a glass of coffee? If I were you, I would say, please give me a cup of coffee. Right? So maybe coffee is not as good a candidate here as milk, or maybe water, or maybe juice. Right? So is this, so this language, tell me now, अपने वो क्या था वहाँ पे एक और example लिया था ना अपन ने पहले, Anyway, so most of the words, almost all of the words, something like 99%, they are not good candidates here. Now, which is the word that appears maximum times in a normal average English corpus? So, the appears 7% of the times. If you take a large enough corpus, the appears 7% of the time. So, if your corpus has 1 billion words, then 70 million will be just the. I have the, and here I have a question mark, right? Even though if you go frequency wise, this word appears 7% of the times, even though you have thousands of the words, it is still not a good candidate for here. So, the will only be a mistake in the document and it won't be the correct. So, if you go by frequencies, there are issues. We need to learn a lot of things here. Now, tell me, water, juice, wine, we said the movie is good, the movie is bad. Bad and good were opposites of each other. In this case, what kind of relationships are we talking about? Or let's say just the movie was, help me fill this one. The movie was good, okay, wonderful, awful, pathetic, right? But good is a candidate here, so is bad. And are they equally good candidates here? Maybe yes, right? So, even though they are opposites of each other, but here they fit really well. So, you keep on making sentences in English. You will see that there are places where, so everywhere. So, let us say if I give you, choose any of these words and I mask this one. I keep a fill in the blanks here and it is, please give me a fill in the blanks of water. What will it be? Glass, cup, what else? Bottle and so on. You will have different words coming here, and in that sense, is water related to juice? Because in this sense, because they can both fill in this particular place, water is related to juice, water is related to wine, coffee is related to, all these things are related to each other in what sense? At a broader level, they are all things that we can drink, right? They are all drinks, okay? So, their representation, so representation of water should be closer to car or representation of water should be closer to juice. Now, if I ask you this question, I want to test drive a, fill in the blanks. Will you fill water there? Not anymore. Their good candidate may be car, truck or whatever, okay. So, different words, we want this relationship to be captured. How do you do this? While you can do that, कोई दूसरा सेंटेंस दो भाई जहां पे बाकी ड्रिंक्स नहीं फिट होंगी, सिर्फ वाटर फिट होगा. Exactly, that's better. Now here you won't have wine, right? So human body is 70% water, right? Nothing else will come here. So words are related to each other and this particular thing is exploited by Word2Vec. Okay, and there are so many other examples. Let me just go to internet and see if we.
सर इसमें mediums and clauses होंगे तो हमको कैसे
Sorry,
mediums and clauses
we have just started talking about one of the most celebrated algorithms in AI and deep learning. Okay, so it will take us some time. And क्या ढूंढने वाला था मैं? Examples. अरे यार,
सर ऑन स्क्रीन कीबोर्ड चालू कर लो
अरे यार ये क्या है भाई? Whatever now. Okay, let's see if leave it. So the movie was bad, pathetic, awful, awesome, and so on. So you have relationship between the words. Now we want to use this particular aspect that words are related to each other, and you can't just fill in the blanks just like that, right? How do you find relationship between the words? What word2vec does is the following. So let's say my sentence is again the same. Please give me a glass of water. So let's say we have this sentence. I want to make an algorithm that gives me, so right now we are using one hot vectors for this. Okay. So, but I don't really want to start word2vec today, and now I have a good thing. So I want to make vectors for these words. Yes, in fact it's a good thing to do this before word2vec. Okay, I want you to give me vector for this, or in fact king, queen, I want you to help me figure out what will be a dense vector for this. What will be the dense vector for these four words? Here I have my features. Yes. So for example, features can be that's a very, thank you so much. So let's say gender. Actually masculinity was better. Okay? So but okay, gender. Let's say we are assuming there are only two genders, so no offenses to anyone. Only males and females. Okay? Now, yes. So we can assign 0 and 1. Okay. Now king, so let's say 1 is male, 0 is female. Again, no offenses, zeros and ones are just one. So king, feature will take value 1. Queen, this particular feature will take value 0, 1, 0. What other feature can I have? Let's say royalty takes value 1 or 0. So for king 1, for queen 1. Okay. What else? Give me more features now. Huh? Power. Power, I think royalty will capture that. Yes. Yes. अगर इसमें हेल्प नहीं कर रहे हो तो मतलब पूरे 2 घंटे से तुम लोग नहीं सुन रहे हो. दिस इज व्हाट इट मीन्स. यस. तो बाकी लोग भी सोचो. What other features can be there? अरे रॉयल्टी को छोड़ दो, दैट इज डन. You see, something for which there will be zeros everywhere. Think of it that way. For example, is president no is whatever, yeah. Right? So is animal, that, thank you. Is animal, and right now we are assuming human beings are not animals. So 0, 0, 0, 0. Maybe let's say is plant 0, 0, 0, 0. अब कुछ ऐसी चीज दो जिसमें हाँ इज ह्यूमन, वन 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 वन. मोर फीचर्स भाई, वट एवर. आई वॉन्ट मोर डिस्पर्स नाउ. Long hair I already thought of, but kings, assuming kings don't have long hair and women do have, no, but no, I don't want to get there. Is nahi. No, you have to give me more, but up this side se nahi. This one, yes. Is educated. No, I won't take this. Something else? Drinks water everywhere will be one. I don't want everywhere one now. I want this person. More. Is rich. अरे चुप रहो. Yes. What else? Color. Okay. Fine. I don't want to go there either. Race. एक बार छोड़ता है. Is servant. Awesome. Thank you. Because we did not have, yes, servant की spelling में A-E-A. So is servant 0, 0, 1, 1. I am attaching. Is I think we have enough. Okay, so we are having, I wanted to do this, I didn't want to come up with a list, I wanted to do this here. Why? It has taken us roughly 10 minutes to come up with these bogus features, right, on which we are not really doing well. So think of it this way, if you were supposed to make these features by hand, not just for these words but for 30,000 words, and 30,000 words when we are being liberal, because English otherwise has more than 1 million, 2 million vocabulary size. Assuming you want to make a vector of size 50, let's say 50, how many features will you need? 50. For every word you will have some numerical value assigned by hand, and that will become your feature vector for king. Similarly for queen. Now if you see, let's try to see this. So this is feature vector for king, queen, man, woman. Which ones are closer? See, if you see, king and woman differ only at the gender. Okay. Similarly, man and woman only at gender, but if you see king and man is rich, royalty and servant, right? So things, so in some sense you want king to be closer to queen, and in other aspects you want king to be closer to man, and so on. And if you start doing this for 30k words or for millions of the words, this is a hopeless task to do, but people have done it. They've tried to make features for vocabularies, right? And it just does not work really well. Okay? Can you help me more? Because what word2vec does is, word2vec simply automates this. And that is where the beauty of that algorithm lies. Right? Even 10 years after, so word2vec was published in 2013. Abhi recently 2023 mein this paper got the Test of Time award or something like that. It was one of the really seminal papers for natural language processing. So let me see the time. Okay, ठीक है, आज वैसे ही बोर हो गया मैं. So I'll wind up things by saying this: if you start making these features by hand, then that's a very tedious task. We chose only those features which can take values either 0 or 1, but nobody stops you from taking numerical values as well. Maybe they will bring much more richness to the representation of features, right? But it's and let's say if we come up with 50 features, does it mean we can't have 51? Right? So even if we start enumerating everything, that will not capture the full essence. So this is what word2vec does. It will give us dense vectors, but will be much better than what we do by hand.